Okay, everyone, this is section 4.3 that we are going to be working on today. And section 4.3 is going to be our sum, difference, and cofunction identities. Sum, difference, and cofunction identities. Okay, so at this point, this is where you need to do something. You need to pause this video and you need to read page 246 to 249. Okay, 246 to 249 are going to have the proofs of these identities that we're going to use today. Now, the summary of the identities is on page 250. The summary is page 250. That is something that I will give you on test, will be those identities. But, and it's one thing just to be able to look at them and use them, but it helps you if you know where they come from. Now, I could try to prove all these to you and could very easily, but I don't know that you want to watch videos after video after video, 30 to 45 minutes each of me proving these things when you can just read it in the book, okay? Because the proofs are very easy to understand, but the summary of the identities is what you can use to work this. Now, I'm going to show you how to work some of the problems like we're going to have with them, but you will need to read the proofs. I won't require you to prove them, so to speak, but it does help you understand the identities a little more. And what you need to realize is, originally cosine, cotangent, and cosecant were supposed to be complements of sine, complements of tangent, and complements of secant. So that's why we call them cofunctions of those particular functions. So it's it will help you learn some little tidbits of information like that will make these things a little more understandable for you. Now, I'm going to help you with today in this video with how to use them, how to work them out. It's up to you to read those proofs. But example 1. Okay? Example 1 says simplify the sine of x minus pi using a difference identity. Using a difference identity. Alright, so of course this is a difference of sign. Now once you have referred through once you've read through all those proofs, hopefully you'll realize that the difference identity for sine is this, equals sine x cosine y minus cosine x sine y. Okay, so x goes in for x, pi goes in for y here. So we simply have to write the sine of x times the cosine of pi minus the cosine of x times the cosine of x, times the sine of pi. Alright, so what is the cosine of pi? Well, the cosine of pi we know, that is -1. So that's -1 times the sine of x Alright, well, what is the sine of pi? We also know that as well. That is 0. So that's 0 times the cosine of x. Alright, well, that's going to cancel out because 0 times cosine is 0, so it's not really going to matter to our problem. So really what we have is negative sine x here. So the sine of x minus pi equals negative sine x. That would be how we simplify that. Okay? That would be how we would simplify it. Alright, well, let's look at another one. Let's try another one. Let's look at the cosine of x plus pi, and let's simplify it using the appropriate identity. Well, obviously this is addition, so if you look at your sum identities, we have a cosine of x plus y identity, which is cosine x cosine y minus sine x sine y. Okay, so cosine of x plus pi is what we have here. So this is going to be cosine x cosine of pi minus sine x sine of pi. Okay, well, again, cosine pi is negative 1, so that's negative 1 times cosine x. And the sine of pi is 0, so that's 0 times sine x. Alright, so those cancel. So we have negative cosine x as our answer there. Negative cosine x is our answer. Okay? So, now you can double check this using your graphing calculator. If you've got a graphing calculator, you can go to the Y window and type in cosine parentheses x plus pi, and then in Y2 you can type in negative cosine x. And when you graph it, if you come up, if there's only one graph up there, then you know you got it correct. If there's not, if there's more than one graph, you know you missed it. Okay, so identities should produce the same graph like that. Ooh, that's a big hint of information there. Identities should produce the same graph like that. Now let's look at a more practical use of this. Okay, for instance, find the exact value of cosine of 15 degrees in radical form. I'm sorry it's taking so long. This pen's a little slow today. Radical form. Okay, so, well, I don't know about you, but I don't know the cosine of 15 degrees. I only know cosines of the angles on the unit circle. So, this is the application part. This is where your sum and difference are going to come in handy. Because, think about this. I can rewrite the cosine of 15 degrees as the cosine of 45 degrees minus 30 degrees. Now notice what I did there. I took two angles that I know, two reference angles that I know, 45 and 30, and I was able to get my 15 out of that with a difference. Now what I've done is I've changed this into a difference problem, a cosine difference identity. Okay, so when I rewrite this, remember my cosine difference identity, the cosine of x minus y equals the cosine of x, cosine of y, cosine of x, cosine of y, plus sine of x, sine of y. Alright, so when I get ready to break this apart again, I can rewrite this as the cosine of 45 degrees, the cosine of 30 degrees, plus the sine of 45 degrees times the sine of 30 degrees. And at this point, you are probably writing this faster than I am. And that should be sine of 30 degrees. Okay? So, what is the cosine of 45 degrees? Well, the cosine of 45 degrees is 1 over the square root of 2 times, what is the cosine of 30 degrees? Well, hopefully with your unit circle, you know it's square root of 3 over 2 plus, what is the sine of 45 degrees? Well, the sine of 45 degrees is 1 over the square root of 2. And what is the sine of 30 degrees? Well, that's 1/2. Okay, so what we really have here is we have the square root of 3 over 2 square roots of 2 plus 1 over 2 square roots of 2. So what does that give us? We can write this as the fraction square root of 3 plus 1 all over 2 square roots of 2. 2 square roots of 2. Okay, so that would be a way for you to figure out what the cosine of 15 degrees is. And that's what it is. Square root of 3 plus 1, 2 square roots of 2. Now, you can type that in your calculator, square root of 3 plus 1 over 2 square roots of 2. If you type it in correctly, get your answer, and then go make sure your calculator is in degree mode, type in the cosine of 15 degrees, see if you come up with the same decimal answer. That'll be a way for you to double check yourself to make sure you have this correct, okay? Be a way for you to double check to make sure you're on the right track. Alright, so let's look at another example. Another application kind of example of this would be, alright, find the exact value of the cosine of x plus y, okay? Get up, well, alright, so find the cosine of x plus y given the following. Given sine x equals 3/5, cosine y equals 4/5, and x is in quadrant 2. Okay, x is in quadrant 2. Now look back, make sure you know what your formula, what your identity states. Your identity states that the cosine of x plus y equals the cosine of x, cosine of y, minus the sine of x sine of y. Now this is great. I already know what sine of x is, and I already know what cosine of y is. I just don't know what cosine of x and sine of y are. Well, that's where our Pythagorean identity comes in, our fundamental identity here. Okay, so we know sine, so this is 3/5 squared plus cosine x squared x equals 1. Now 3/5 squared, that's 9/25. So we need to say cosine squared x equals 16/25. Notice what I did there. 1 minus 9/25. I just subtracted my 9/25 right here from both sides. Okay? I subtracted it from both sides. Now take the square root to find cosine x. And so the square root of both sides here gives you 4/5. Now, what you've got to realize though, this bit of information right here is going to come in handy. X is in the second quadrant. Well, we know cosine is negative in the second quadrant. So that's a negative 4/5. So we get to put a negative 4/5 in here. Now, we can do the same process again and find sine y. We know cosine y, so sine squared y plus cosine squared y, and cosine squared y would be 4/5 equals 1. And so you could solve this the same way we did the previous one, and you could find sine squared y that way. And if you do that and you find sine squared y would be 3/5, believe it or not, because sine is positive in the second quadrant. So we have negative 16/25 minus 9/25, which is going to give us negative 25/25, which equals negative 1. Which equals negative 1. Alright, so that would be a way to solve that given those two values. Alright, so be able to do that. I guarantee you'll see one like that again. Okay? Be able to do that. Last but not least, I can't let you get out of here in section 4.3 without you doing some kind of identity. I mean, come on, folks. We've got to do some kind of identity. That's where life is fun. It's when we have an identity. Alright, so alright, which side do I want to do first? Well, now, the rule of thumb states just do the complicated side first. Well, both of them are pretty complicated. But what I automatically know on that right-hand side, when I see that sign of x minus y, I know that that's a difference identity. So I'm going to start there and see if I can't get what's on the right-hand side. So what's the identity for sine of x minus y? Well, that is sine x cosine y minus cosine x sine y all over the sine x sine y. Now at this point, I'm going to break apart my fraction. I've got sine of x, cosine of y, all over sine x, sine y, minus cosine x, sine y, all over sine x, sine y. So the sine y is canceled, the sine x is canceled. So notice what I have here. I have cosine y over sine y, which is cotangent y. I have cosine x over sine x, cotangent x. We have verified our identity. Okay? So be able to do that, be able to use those functions to do the identities. Now, I stuck mainly with the sum identities and difference identities in all the things I did today, all the examples. Now, there are some cofunction identities that that you may have some practice on doing. So be careful with those, as it's just a matter of plugging in the identity to get what you need. Okay, so don't let that fool you as you use those. And I may, if I get too many questions on those, I may post you an example. But I think you will be fine if you can do what we just did. I think you can definitely read the cofunction identities and be able to manipulate those some way somehow. Okay, so I have faith in you. I know y'all are doing good. So if you have any questions, please don't hesitate to ask. And this has been section 4.3.